Hello all, hope everyone's doing good. This is Nikhil here. I've been working in tech and programming for the last few years, and I find data structures and algorithms really interesting. And I just thought I'll share my journey by solving problems on Leetcode. Hope this helps, and let's get started. Let's first talk about tech interviews. A lot of people are skeptical of these type of coding interviews and question why we need to solve these problems when you'll be doing something different on the job. While that is true to some extent, this interviewing process has been proven to be helpful for companies, and it's one of the best ways to evaluate your technical ability, logical thinking, your communication skills, problem solving, and how you handle different situations. So there's a reason why big tech companies like Google still use this process. And it might be overwhelming at first, but with the right process, structure, and lots of practice, you can get really good at it. Let's dive into it and discuss about the problem solving methodology for approaching and tackling different questions. I've broken it down into 5 steps so that we have a clear process of the things that we need to do when seeing or approaching a problem. It's good to have this framework or sequence of steps so that we are clear on all the things that need to be done end to end in order to arrive at the solution. The first step is to understand and analyze the problem. We need to think about the goal of the question, the inputs that can be there, and the logic or algorithm that needs to be implemented in order to arrive at the solution. It's helpful to ask questions and make sure that we clearly understand the problem at this stage. The next step is to think of different approaches to arrive at the solution. Oftentimes, a question can have many different solutions, and it's our goal to arrive at one of the most optimal ones. It's good to start off with the most straightforward approach, think about the pros and cons of the approach, and then try to optimize it. This way, in an iterative manner, we can slowly optimize and improve our solution. It's good to use examples at this stage, and it also helps communicate our thinking process with the interviewer. May not be fully clear on the approach yet, but at least getting an idea of how it can be done and the most optimal one. Then later on, while actually coding it, slight tweaks can be made in order to make sure that the solution is good. The next step is to write pseudocode, which is basically a sequence of steps which will be translated or implemented as code. This can just be written in plain English or a sequence of steps which denote like programming techniques. Having this pseudocode is helpful so that any confusion that we have in our mind is clarified over here rather than jumping in and we're in the middle of solving a problem and coding it and then we're stuck. So pseudocode gives us that rough run through of the different steps that need to be done, and it's really helpful not just for these programming interviews or coding questions, but for software engineering in general. It's good to jot down or plan what we're implementing or doing before actually jumping in and coding the solution. Now that we have pseudocode, we mostly know what to do, but one more important aspect that's often overlooked is the different edge cases and the range of inputs that we can face. So we need to think about all types of inputs and different edge cases or corner scenarios that might happen and how these situations are handled by our solution. We also need to think about the coding approach. So far, we've mainly been thinking about the logical method that we'll use. We also need to now be clear on the data structures being used and the the different programming techniques that we'll use to implement the solution. Please note that in order to get to this stage and start solving questions, you should be familiar with basic programming techniques and common data structures used. In this series, I'll try to solve as many problems as possible and use Python as the programming language. Many people prefer Python because it's less verbose and easy to explain and understand. But you can choose any language of your preference. And I would suggest first learning and being confident with a language before jumping in to solve problems. And now that we have a plan, let's go ahead and solve one of the easy and common questions using this framework. Okay, so let's solve the two-sum problem, which is question number 1 on Leetcode. Quite a common question, but an interesting one to start with. Given an array of integers and an integer target, return indices of two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. Return the answer in any order. So for this problem, we have list as an input, and we need to find two numbers that add up to target. So let's look at this example where we have 2, 7, 11, and 15, and we have a target of 9. So we need to find numbers so that they add up to 9. And to start off, we can think of a brute force way, which means we can go through the entire list and find those two numbers. And the indices for these would be 0, 1, 2, 3. So let's call this approach 1, which would be brute force. We start with 2, and then iterate over the rest of the list, and the number that comes next is 7. 2 plus 7 does add up to 9, which means we arrived at the solution already. And because they mentioned that this can have exactly one solution, we can return the result, which is 0, 1. And let's talk about the space and time complexity of this. Since we are iterating over the list multiple times, the space complexity would be big O of n squared. Let's see how we arrive at this. So in this particular example, we got the result in the first attempt, but let's say we had a big list with a lot of numbers, and we had 2 and 7 in the end. So in that case, we would have started with this, gone through the entire list, then started with the second one, gone through the entire list, through the third one, and the entire list. So finally, we would have arrived at the solution in the end, which means we have a nested loop and n times n, which would be big O of n squared. And the space complexity with this would be time, and the space complexity would be big O of 1, because we're just returning the result and not saving anything. I think this can be done in a better approach. So what we can do is, in a lot of these cases where we want to use existing results or things that we've seen already, we can use a dictionary. We can use a dictionary to save the different elements, and when we iterate or glance over a certain element, we can see if the dictionary already has it. And let's have our dictionary with keys and values, and initially it's an empty dictionary, and we start with the first one, which is 2. What we're looking at is our target minus number, if it's there or not in the dictionary. In this case, it would be 9 minus 2 equal to 7. It's not there. So what we do here is save 2 into the dictionary. So we have 2, and the index can also be saved here, so at index 0. Now we go to the next element, which is 7. So in this case, we have 9 minus 7 equal to 2. 2 is already there in the dictionary, so you just look that up and it's there at index 0. So in this case, we just return the result, which would be 0, which we saw previously, and then the current index. So would be 0, 1. That greatly solves the problem and makes sure that we're looking at each element only once. Let's write down the space and time complexity for this. So time would be O of n because we're just going through the list once, and space would also be O of n because we have a dictionary which can be the size of the entire list. This is a good balance because we're saving a lot on the time complexity. Now that we know how to do it, let's quickly write pseudocode to solve this. So for this, what we're doing is we have an empty dictionary. Let's call that as store. Then we want to iterate over the list. So we iterate over the list and we check if target minus num in dictionary in the store. Then we just return store of target minus num, comma, index. While iterating, I mean, you can just assume that you also get the index in each step. If not, we just need to add the current element to the dictionary. So it would be store of num equal to index. Let's say we run through the entire list and do not find anything. We can just return none. In this particular question, they've mentioned that each question will have exactly one solution, so we won't arrive to this part of the code, but it's always good to have this in place. That basically solves it, and we need to think of any edge cases or scenarios that we might come across. And in this case, there's not many edge cases actually. The constraints that we can see are the length of the list can be 2 to 10 power 4 and other ranges for the numbers, but I don't think that would affect the solution much. You can go ahead and code the solution. Let's code the solution that we discussed and have the pseudocode written for. So we have the basic structure for the function here. Let's initialize our dictionary, and I think it's easy to understand if we call it scene, which would store all the elements or numbers in the list that we already saw. Next, we need to iterate over the list. So let's do for I in range this will basically go to from 0 to the end of the list, and we want to check if target minus the current number is in the list. So if target minus if this is there, then we can just return the result, which would be the dictionary of target minus nums of I, which is the number that we already saw in the list, and the current index. So we're returning both these indices, and this would be the result. If not, we can just do scene of the current number, which is nums of I, equal to I, which is the index. We don't need this because in this particular solution we would be having exactly one solution, but it's good to have a return statement. And one more thing to note here is that in often cases like this, we need not have an else statement, because if that were true, the function would return and we wouldn't come here. All right, so let's run this code to see if it works. Got the example that we discussed with 2, 7, 11, 15, 0, 1, which is 2, 7 is the output, which is what's expected. Can go ahead and submit this. That works. And I mean, you don't need to be very specific about the percentage of submissions that this is faster than this. The more important thing is the time and space complexity, because you can see that I've submitted the same solution multiple times, and I've got 52 milliseconds and 73 milliseconds once, which changes this percentage a lot. So don't be super concerned about how faster it is compared to other solutions. The more important thing to consider is the space and time complexity of the solution. Hope this helps. This was kind of a bit detailed so that we can get the idea and approach for the methodology that we'll be using for approaching each question. But going forward, we'll be more precise and try to do as many questions as possible.